So we are proceeding with another example. Saying solve the equation. Solve the equation. Log of x base 2. Log of x base 2 plus log of 2 base x equals 2. So when they say solve, that means they want you to look for the unknown. They want you to get the value of x, which we need to know. Now you can see, first observe the equation. This is log of x to base 2. Then here there is an interchange of the base. This is log of 2 to base x. So we are going to apply the other rule which we have already proved, that take it back to the original base. Solution. We can change log of 2 to base x into log of x base 2. So let log of 2 base x equals p. So what happened, this is 2 is the same as x power p. Our interest is to take it to base 2. In taking log at base 2 on both sides, taking log at base 2 on both sides, what's happening? Becomes log of 2 equals log of x power p base 2. From the rules again, the power is dropped. Log of 2 is get 1 is the same as p log of x base 2. Can you make p alone? P becomes 1 out of log of x base 2. But p was already log of x base 2, log of 2 base x equals 1 out of log of x to base 2. So you are going to substitute it here. Where you see log of 2 to base x, you're going to say 1 out of log of x to base 2. So we proceed. Log x base 2 plus, this one was already changed, 1 out of log of x to base 2 equals 2. Now you can see log of x to base 2 is common everywhere. So when it is common, you're going to say let log of x to base 2 equals y, or any other letter. Let log x base 2 equals y. So when we see x base 2, put a y. This becomes y plus 1 out of y equals 2. So can we try to multiply out? So get y squared plus 1 equals 2y. So this is the same as y squared minus 2y plus 1 equals 0. Then you can factorize this one because it's a quadratic equation and it's a perfect square. But if I move to know that this is a perfect square, you can use our idea of products and sums. So what is the product? The product is 1 and sum is negative 2. Sink of two numbers, we're looking at now at our factors. Sink of two numbers, when you multiply you get a positive 1, and when you add you get a negative 2. So what are the factors? Factors, I can see there is negative 1, negative 1. Because negative 1 times negative 1 you get a positive 1. And negative 1 plus negative 1 you get negative 2. So we add, this is y squared minus y, again minus y, plus 1 equals 0. Then we try to factorize out. What is common here is y into y minus 1. And again, what is common there is a negative 1 into y minus 1 equals 0. So I've got y minus 1 again into y minus 1 equals 0, which is written as y minus 1 squared equals 0, which represents a perfect square, as we shall be looking at them in front there. So after coming out with that, we are free now to solve for the value of y. We have said y minus 1 squared equals 0. You can take the square root on both sides. I remain with y minus 1 equals 0. This one is a negative. When it goes there, it becomes a positive. So y equals 1. But recall, what was our y? But log of x to base 2 was equal to y. Now, we have already got the value of y. The value of y is already 1. So what I'm going to do is this. Where there is y, substituting that true value, log of x base 2 equals 1. From our index, x is the same as 2 power 1, which means x equals 2. We said any number power 1 is the same as that number. That's how we handle such a kind of numbers related to that. So move to another example. Example next. Moving to example 4. Sort of for n in log of 4 base n plus log of n squared base 4 equals 3. So what I'm going to do is this. The first one is log of 4 to base n plus log of n squared base 4. You can see the base has already been interchanged. So what we're going to do, we are going to change one base to be related to another. So move on, log of 4 base n plus, we throw this one here, 2 log of n base 4 equals 3. Which one can we change this one? Can be 1 out of log of n to base 4 plus 2 log of n base 4 equals 3. You can see now the bases are related in one common base. So you can say let log of n base 4 equals y. What happens becomes 1 over y plus 2y equals 3. Then we multiply solved by the LCM. We are getting 1 plus 2y squared equals 3y. So this becomes 2y squared minus 3y plus 1 equals 0. We also look at the product and the sums. So our product equals 2 and our sum equals negative 3. Can look at the factors. Think of two numbers. When you multiply, you get a positive 2, and when you add, you get negative 3. So you can say we are going to have negative 2, negative 1. So instead of this, bring in these factors. What happens? We are getting 2y squared minus 2y minus a y plus 1 equals 0. Two numbers in a bracket, two numbers in a bracket. What is common is a 2y. I remain with y minus 1. And what is common is minus 1. Into y minus 1 equals 0. So what are we having? We're having 2y minus 1. Again, into y minus 1 equals 0. We say either 2y minus 1 equals 0. Take that one there. We have remained with 2y equals 1. Then y equals a half. And or y minus 1 equals 0. Y equals 1. So I've already got our two values of y. But you need to go back and ask, but what was y? What was y? But log of n base 4 was equal to y. We now start applying for the first value y. For y equals a half, we substitute in, you get log of n base 4 equals a half. So the index law comes in, n equals 4 power a half. What is n? And we said any number power half is the same as the square root. What is the square root of 4? Is 2. Also come to this one. For y equals 1, we also come in log of n is 4 equals 1. What is n equals 4? 1. So what is n? N equals 4. So we have already got the values of n. Conclude and say therefore n equals 2 and n equals 4. We have already got what has been in question. So that's what we normally do when it comes to such a kind of the numbers. And I normally request you always practice more. Get understanding pure mathematics book, get pure one book, go to chapter 9, open there, calculate and discover much more on that.